Hello, my name is Trent Waltz, and today I will be explaining this projectile problem. Um, for my math project, I chose to determine or to figure out this problem. If we were to throw a baseball up in the air at an angle of 60 degrees at 20 meters per second, how high does it go? In order to find the answer to this problem, I first had to lay some basic ground steps, some baby steps, if you will. I first just made a simple graph, you could call it, showing just the trajectory of the baseball going upward at 20 meters per second, and the angle 60 degrees. Now, we know if you throw a baseball directly upward, it's going to form in kind of a parabola shape, like we see here. And it'll always be going forward at a constant speed, but going up, we notice that the trend upwards is a lot of speed initially going up, but as we start to reach that vertex point, the speed gradually decreases until we see a trend of the speed of the velocity going down, such as here, where it starts off a little slow, but it keeps falling faster and faster until it hits the ground with a thud. Now, getting on to the more mathematical and equation focused part of this problem, I set up this equation by using triangles. So as we can see here, regarding this special right triangle, I was able to infer from the problem, due to our 60-degree throwing angle, that this was a special 30, 60, 90 right triangle. And doing this, I was able to calculate the different sides using SOHCAHTOA in order to find the horizontal and the vertical velocity. This equation right here represents the vertical position of the baseball on its travel from your arm. And using these equations, we can plug these in to this equation in order to find the time of the baseball, which is necessary in order to finding the meters per second that it's falling. So moving my audience over here, we can see that this is the derivative, and by plugging in our equation that we have over here into the derivative, we will be able to find the time it takes for the baseball to reach its vertex point on the parabola, aka at zero velocity. We set the velocity here equal to 0 in order to find the time it takes for the baseball to reach its maximum height in its trajectory, or aka the vertex on the parabola, when the velocity is actually equal to 0. So just using some simple mathematics, we can clearly see here, basic algebra, bring it down, t is equal to -10 root 3 over -10, eliminate the negative 10s, and you have yourself t is equal to root 3. Now, coming down to the last portion of the problem here, it's quite simple. We simply just take our equation over here and substitute in t in order to simply find the height at which the baseball is at when it's at the maximum point in the parabola. So just, really simple algebra right here. Simplifying, plugging in that square root 3 for t. Remember that square roots, they cancel out just to become 3, and you've got yourself all the way down to here, 30 minus 15, 15 meters of height. I guess that's kind of a weak arm, But hey, what you got, man?